Hello my fellow students and teacher. Welcome to our presentation on theoretical physics.
Today we will be introducing theoretical physics to you, and some of the issues that arise from this particular field of science.
Theoretical sciences are exactly the same as the name translates itself to you. It is theoretical. In that sense, the science itself is created around ideas that may not have been observed by any individual.
That being said, there is no solid evidence to support whether or not these theories hold true.
A form of theoretical science is theoretical physics, a new form of physics that is rapidly becoming the next forefront for future ideas and conceptions.
Theoretical physics is based upon the use of mathematics to find and discover new theories that do not currently fit into mainstream sciences.
For those students who still do not know what we're talking about, you might recognize the following person.
This is Dr. Michio Kaku. He is a theoretical physicist and string theory popularizer. Some of you may have witnessed him in many science documentaries.
Moving on to space-time theory, we would like to introduce a little theory to the class in hopes that we will confuse you and at the same time help you understand what we're saying.
Space-time theory is as follows. Let's say we have a particle, and because we are very original people, we will proceed to name our particle Bob.
Now imagine Bob travels a certain distance to the point Bob 2 and space Bob 2. He has used an amount of time given as t.
Now imagine Bob is in fact a photon. If it must take a certain amount of time for the fastest known entity or particle to travel a distance from Bob to Bob 2, does it not mean that space and time are both relative?
Now imagine Bob has gained special powers, the ability to warp space and exist on the grid plane we name here as space.
Now imagine Bob warping the space in front and behind him, making the distance in front of Bob shorter, behind him larger. Theoretically, Bob can travel the same distance in less time, as long as there is a strong enough energy source to provide such warping abilities. Space and time are relative.
This theory itself is very simple, but there are a few problems with the theory itself and in the bigger scope of science, theoretical sciences as a whole.
Theoretical physics is based solely upon mathematics. Mathematics is based upon a number line similar to the one shown below. Note that the number line is man-made.
According to our current models for science, our science's truth is based around the idea of falsification. Therefore, the following statement can be made. If it cannot be disproven, it is true.
This is a problem among the scientific community, since although phenomena and the natural world is what we were set out to describe, in the realm of theoretical physics, however, we describe things that may or may not exist.
SHM, or spontaneous human combustion, is a series of cases that include humans suddenly bursting into flames. One particular theoretical physicist suggested that it is caused by an unknown particle, the pyron.
The pyron is akin to other particles that exist in this field of physics, for example the antimatter or the graviton.
Let us introduce you to two new particles, so small that you can't even see them. We call them the Hugo and Xiang respectively. This is truth, because you cannot disprove it.
From these examples we can draw out the following problems. Firstly, there is the confirmation bias. In the case of spontaneous human combustion, there are many skeptics who believe that the pyron doesn't exist, while others come to conclusions such as electrical signals in our body starting the combustion cycle. These people are convinced with their own theories to the extent that they are willing to make their own evidence. The pyron is a currently unfound particle, and so there isn't any evidence that it exists. But since it cannot be falsified yet at this time, some physicists have decided that it is possible for such a particle to exist.
The Hadron Collider is a good example of people who have become biased due to their expectations for the outcome. One use of the Hadron Collider is to search for the graviton, which is said to escape our dimension after a high-speed collision.
Next, we have the effect of authority. Authority can come in many forms, but we tend to believe something because it is supported by someone of a higher status.
For example, I'm sure my fellow students who sit in front of my colleague and I today do not believe in the existence of the Hugo and Xiang. We do not have any notable accomplishments yet that grants us any power or notable status, but everyone believes that electrons exist because they're told that it exists by teachers, books, and many other sources.
Now we shall move on to the third problem that we may extract from our given examples. Groupthink. It is when a person or people believe in something because the majority of people believe it is true. They are inclined to perform an action of conformity according to the individuals who surround him or her. In this case, take the electron for example. Since it is widely accepted that the electron exists, we conform and state that it definitely exists, even though we have not witnessed one firsthand.
In conclusion, although theoretical physics have yet to be disproven, there are tensions between various groups because of different beliefs in how science should be perceived. Should it be supported, proven, or should it construct itself around falsification? Perhaps science today shows only a fragment of truth, or a model of truth that cannot be falsified, even though it isn't real, and we only currently pursue truth that fits into our current model of the real world itself.
Our truth today is affected by those around us, our expectations, and those who hold higher social status. Should truth be created by those who stand higher up on the social ladder, or by the majority of the public? These questions are fundamental to fully understanding the conflicting ideas of how science should be conducted, and the problems our current scientific models face.
Below we have some video links that we could go through if there's enough time. One showing conformity, another showing the power of authority, with a reproduction of Milgram's experiment, spontaneous human combustion and space warping. For those who are interested, we have one final ultimate question for you to tackle.
In religious studies, there is a constant conflict regarding the meanings and purpose of life.
The question is whether science, and the undiscovered realms of science, should be pursued, or is religion and culture the priority of mankind?
We hope you have enjoyed our presentation. Thank you for listening.